This lesson is going to be very similar to the last lessons. The difference is that instead of growth, it's now decay functions. The first thing we're going to be doing is writing a function rule. They're going to give you a t-table with ordered pairs or a graph, and your job is going to be create a rule or an equation. That generic equation is going to look the same as last time, and you're going to use the same steps. So let's say we have a t-table with the following ordered pairs. We have -1, 1/8, 0, 1/2, 1, 2, and 2a. Your goal is to find the a and the b, leave the f of x, and leave the x in your final answer. You're going to want to find a first. You're going to substitute the ordered pair with the 0 in it. Okay, so here's the ordered pair where x equals 0. This is my x value, this is my y value. Here's the y, here's the x. 1/2 equals a times b with the power of 0. When I think of the power of 0 is always 1, so I'm thinking of this term as 1. Anything times 1 is itself, so a is 1/2. And I'm going to substitute that back into the function before I start the next step. Okay, now I want to find my b value. And to substitute that, I'm going to sub in the ordered pair where x equals 0. Okay, so I'm subbing in the ordered pair where x equals 1. My x value is 1, my b value is 2. It's going into this formula right here. 2 equals 1/2 times b with a power of 1. Well, think about it. 3 with the power of 1 is just 3. So b with the power of 1 is just b. To get b by itself, I'm going to have to multiply this to bring 1/2. Sorry, I'm going to have to divide this to bring it to the other side. But we can't divide fractions, so I'm going to multiply by the reciprocal instead. So my b is 4. Now that I have a b value and an a value, I can plug it in to this generic formula. F of x equals 1/2 times 4 with the power of x. You're going to try this, and you're going to write a function for these ordered pairs. -1, 5, 0, 1, 1, 1/5, and 2, 1 over 25. Push pause and try that now. Okay. Next, we're going to be graphing. Graph an exponential function. They're going to give you an equation or a function, and your job is to graph it. Still, the only way to graph these is to make a t-table, pick your x values, plug them in to find your y's, and those create ordered pairs. So we're going to graph y equals 1/3 with the power of x. I still want you to use 5 values, and I still suggest you use -2, -1, 0, 1, and 2 because those are the lowest values. If you choose any values higher than that, 3, 4, 5, -3, -4, -5, you're going to get really big numbers and have a huge graph. I'm going to plug these values into this equation. I'm going to start easy. I'm going to start with 0. Anything with the power of 0 is always 1. I'm going to plug in 1. That's just a third, it's just itself. parentheses, 1/3 times 1/3. Or we learned at the beginning of this chapter that you distribute the 2 to the numerator and the denominator. So 1 squared is 1, 3 squared is 9, 1, 9. The negative exponent tells me to take the reciprocal of 1/3, which is 3 over 1, or 3. I'm going to take the reciprocal of 1/3 again, which is 3 over 1, or 3. When I take the reciprocal, this becomes positive, so my answer would be 9. You could also distribute the negative 2 to the stuff on the inside, so I had 1 to the negative second over 3 to the negative second. Take the reciprocal, and get 9 over 1, which is still just 9. Okay, let's graph this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have an ordered pair -2, 9. -1, 3, 0, 1, 1, 1/3. I'm going to envision cutting this first box into thirds, and I want the first one. And then 2, 1, 9. Same thing, envision cutting that into 9 spaces, and you only want 1. Okay, this works very close to exponential growth. Instead, this is called exponential decay, so we're getting smaller and smaller and smaller. This function will get closer and closer to the x-axis, but it'll never dip below the x-axis to have negative x's. They also want you to identify the domain and range. Remember that the domain are your x values. So you can see that this graph, this is the x-axis on the number line here. This is going to keep on going positive, and this is going to keep going up this way, and it's going to be going in that direction, and that's going to cover the negatives. So the domain, the x values are all real numbers.
Pardon this interruption. Would all students who are joining the forensic team go to Mrs. Capelli's room 304 right now for a very quick photo?
Okay, now the range is the y values. The y values go up and down. So I see now, I'm looking here, I see that this graph keeps going up, but will the graph ever predict to the negative y's? No. So the range is all real positive numbers. I want you to do the same thing with these next equations or functions, but I want you to graph them on the same graph. So I would like you to graph y equals 0.4 to the power of x, and also graph y equals 5 times the quantity 0.4 to the power of x. So make a t-table for both of these, graph them on the same coordinate grid, same coordinate plane. When you are finished, I want you to compare the two. Did one shrink? Did one grow? Is there a vertical stretch, a vertical shrink? Is there a reflection? Talk to me how they differ. Compare them. Okay, lastly, we're going to talk about exponential decay. Exponential decay. This formula is going to look familiar. Y equals A times the quantity 1 minus R with the power of T. Now we're talking about decay, so we're no longer adding. Adding is for growth. Decay, you're going to be subtracting. A still stands for your initial amount. R still stands for your rate. And T still stands for time. Okay, farmer bought a tractor in 1999 for $30,000. The value of the tractor has been decreasing at a rate of 18% per year. Write a function that models the value of the tractor over time. They just want you to write an equation. They don't want you to solve it yet. So I'm going to plug this information into the equation. The initial amount that the farmer bought the tractor for is $30,000. It's decreasing, so we're going to be subtracting the rate. And it's not asking us to solve, so I'm going to use T for the time. Okay, now, what was the approximate value of the tractor in 2005? You are not going to plug 2005 in for the time. That stands for 2005 years. Instead, you have to figure out the time that's elapsed between the time that he bought it, which was 1999, and 2005. You're going to subtract the two to find the time between it. The difference is 6 years. You can plug this into the calculator exactly how you see it, 30,000, parenthesis 1 minus 18%, use a percent sign, parenthesis to the 6th power, or you need to convert this to a decimal. To convert 8% to a decimal, you need to move the decimal 2 places to the left. It doesn't tell us how to round, so you're going to want to round according to money. I'm going to round to the nearest whole number because that's what it, actually, you know what, I'll put it in my calculator. Let's see. Let's see what you get. Let's be more exact. I got that the tractor is worth $9,120.20. Now it's your turn. You're going to write an equation, and then you're going to solve it. The number of acres of ponderosa pine forest decreased in the western United States from 1963 to 2010 by 0.5% annually. In 1963, there were about 41 million acres of ponderosa pine forest. Write a function that models the number of acres of ponderosa pine forest in the western United States over time. And then about how many acres would be left in 2010. Write the function.